All right. Well, hello, I'm Rosario Newman, solution consultant with SVA Software, and thanks for joining this live demo about our BVQ solution for infrastructure monitoring and analytics. And I'm excited to show you today the capabilities of BVQ to deliver insight into the SAN infrastructure for Brocade and Cisco. So in this demo, I will show you how you can lower time to problem resolution with our monitoring ready to go dashboards and our systems health map that shows the health of the entire infrastructure, including the SAN environment, so that you can lower that time to problem resolution when dealing with troubleshooting process to find performance problems in the SAN area. I will specifically cover three main areas during the demo. One area that I'm going to share is about congestion scenarios and how these can cause performance problems and how BVQ can help you identify the cause of congestion in the environment and identify where the congestion is coming from. Second would be on how to identify critical areas before they cause performance issues on the applications and how you can be alerted on these. Also, third, I would like to show you our specialized monitoring dashboards that include an end-to-end view into the entire infrastructure, and that is compute, as well as the storage, and of course the SAN. And I would like to mention that on the SAN side, BVQ supports Cisco and Brocade. On the Cisco side, the performance data is collected via the Cisco DCNM. And for Brocade, we use the REST API to pull data from Brocade. So no BNA is required for that. Okay, let me jump into the demo. Right. This is our predefined and ready to go monitoring dashboard for the SAN fabric. This shows an overall view of the SAN performance information. So we see an overall data rate for receives and transmit and receive, on the SAN fabric. You can select a specific switch to monitor and the time frame that you would like to monitor. The F port and E port peak data rate utilizations are shown here. We've included an area with color-coded yellow and red to show warning in critical areas so that you can easily identify when high workload peaks are happening in the specific data rate. Then we have also included in this dashboard to report on buffer credit weights for the F port and E ports, as well as error counters. So about congestion. So typically congestion, when that occurs in the fiber channel fabric, there are two main causes. The first is the slow drain device, and the second is lost credits. So these are the main causes that as you go through your troubleshooting process, you would have to identify. So being able to detect the indicators of the behaviors of this congestion can actually, and before the performance of the applications is impacted, is critical. So BVQ can help you with that. As you can see here, when we talk about the slow drain device as a cause of congestion, you can easily identify that here with these metrics. So when there's a slow drain device that's causing congestion and an ISL or an F port, usually it's identified via the buffer credit wait. So how long there's a wait on the buffer credits to be available. And this is what we report on here. And in this case, we see that the E port is experiencing a high buffer credit wait utilization over this period of time. So this is an indicator that you need to keep an eye on to see if this is happening over a long period of time or gets to be in a critical situation. The second cause that I mentioned is the lost credits. And here we show the F port and E port error counters. And these help identify this type of congestion when that is related to physical errors or a malfunction on a port or transceiver. These will be the indicators. So the indicators that we report on via the dashboard are the frame discards, the CRC errors, and encoding errors. So you can easily identify when this is happening before it becomes a performance issue. And then I would like to introduce you to our systems health map. This is a view of the health of the total infrastructure. Let me go into the Brocade area. And we can alert. This is a visualization based on an alert engine that includes hundreds of predefined alerts. So here it shows you a list of that information. Green meaning everything's doing okay. Blue is information. So you can actually select one of these and it'll show you the components that are in either a warning or an error state, and it gives you information on what this is related to with recommendations on what to do next. How does this help with determining lost credits when there is congestion in the environment? I can show you that quickly here in the configuration environment. If we go into the Brocade area, for example, we can go into the transmission, and you can easily see here that we have enabled in this environment to be alerted on many of these errors that indicate physical malfunction. So we've enabled these. For example, the link resets, that would be an indicator of a physical error, encoding link failures. So this is a way to be alerted on, and you can receive alerts via email or Slack as well. And like I mentioned, these include hundreds of predefined alerts that can easily enable and disable. And that's on the congestion side. The second part that I would like to mention and share is that we help you basically look at and go through the daily activities and help you look at the health of all the systems in your environment, including the SAN, Brocade, and Cisco. We have different categories that we can alert on. Performance, for example. We have these predefined alerts for performance, for example, switch port state, etc. And then on the configuration side, we can help you determine if your environment is falling out of compliance based on configuration best practices with recommendations on how to fix that. So for example, we have unzoned aliases, unzoned node ports, etc. So this gives you a quick and easy way to keep track of what is not working in the environment and to stabilize the environment. And third, I would like to share with you our specialized monitoring dashboard. So let me go to the top here. This is our specialized dashboard for end-to-end monitoring. So it gives you the ability to look and follow the data path from, in this case, a SAN environment to also the storage layer and the compute layer. So you can go through the whole and follow the data path to look for peaks in the workload and detect bottlenecks in the environment. And you can do this over time as well. For example, in our environment, we have, in this case, in this example, Brocade switches. We also have VMware VMs and IBM storage. So if we start looking at the overall performance of the Brocade switches, we can detect any peaks here and also identify the time frame by hovering over this area or the peak areas. And also here for the fiber channel switch, we can see the data rates and determine where a high workload is happening. And then we offer again the detailed overview that I showed earlier for the specific switch is selected. And we have a table here that shows the port type and the ports on the switch that are actually active. And again, we saw this high buffer credit weight, and we can determine, okay, the highest peak occurred during this specific time interval and follow that data path to the compute layer. So here I'm showing the compute layer now, And we've included here the VMware ESX hosts that are actually involved and connected to these switches that we're monitoring, as well as the fiber channel ports that are being used on the ESX VMs, and the ports that are being used or connected to. And below here are the performance graphs. So we can follow the data path to that specific time frame where we saw a high workload before, and see how this load on the fiber channel switch port that's connected to the fiber channel adapter on the ESX host. So how that load is impacting the fiber channel port. And here we can see the IO rate. So we have the two metrics, data rate and IO rate. Down here we have the latency. So we can detect here quickly a peak on the response time or latency that is occurring for this specific fiber channel adapter on the ESX host, and how that load is affecting the SAN switch. So going down here as well, we can go into the storage layer. This area here for networking is just included so that it's easy for you to follow the data path for the specific time frame you're looking at. So on the storage layer, we have included metrics such as the fiber channel ports on the storage and how that load that's going through those fiber channel ports on the storage are affecting the ports on the SAN switch. So follow that path in the same time frame, and also the IO rates. So as you can see, you can follow the data path to detect where bottlenecks are occurring, and you can look at this over time to determine if there's a pattern or if these workload requirements increased on specific times and over again. And you can easily, again, see how the VMs or the load on the VMs is affecting the fiber channel ports, or how the load of the VMs are affecting the volumes on the storage. So in summary, I've shown you how you can easily monitor your SAN environment, Brocade and Cisco, and reduce that time and cut that time of troubleshooting to get to the source of the problem when there's congestion, and also to keep track of when you're not following configuration best practices in the environment, and be alerted on that. And let's see, we have time now for questions and answers.
Perfect. So Rosaria, the first question we have is, how can you see which VMs are affected by storage?
How can you see which VMs? Okay. Let's see. All right. So here we see on the compute side, we can see the ESX host, the VMware ESX host, and how the fiber channel ports on the host adapter are impacting the SAN ports. That's what the level that we can see in this monitoring dashboard.
Perfect. The next question is, what platforms do you support on the server side?
Okay, so let me go through that. Let's see. This is a nice slide that it can give you a summary. On the compute side or server side, we support VMware, and we also support IBM Power VM. So VMware and IBM Power VM.
Another question for you. How does it extract data for Brocade?
Okay, the data is extracted via REST API. So you don't need BNA as a requirement to be able to extract data.
The next question, can I see when you need to add capacity?
Oh, capacity. Let's see. Let me go back to my monitoring dashboard here. You mean capacity to which area?
I'm not sure. The user just said, can I see when you need to add capacity?
Oh, okay. For example, add more ports. Okay. I would say if you look at the data rates, load over time, and if the load is increasing, data rates on the switch, for example, a specific switch here on the right, you can detect when you probably need to move certain VMs workload off of certain ports. And the way you look at the ports that are connected would be through this table here. So different ports that are active and how they are being used and by which ESX hosts are being used.
Perfect. Great answer. Okay, the last question we've received so far, does BVQ connect to external applications like ITSM applications?
Yes. So this slide shows you a quick overview of what is supported. So BVQ does connect, and it's ready via REST API to connect to external applications, ITSM applications such as ServiceNow or Splunk, for example. And for ServiceNow, we've gone through a lot of improvements where now the topology and performance data that BVQ has and can alert on can be automatically connected and ingested into ServiceNow to be able to create events and tickets.
Perfect. That's all for now.
All right. Well, thank you for your time, and we can end this live demo. And thank you for your time.